Hello, today we are going to cover 4.4 Factoring Quadratics Part 1. You guys will be able to find common and binomial factors of quadratic expressions and factor special quadratic expressions. So before we jump into these, we are going to actually go look at something that I just created over here. So what is on this slide, I like to call a factor chart. You can also look up one of these to use on your homework. It's called a factor chart. You won't be able to use it on tests, but it's pretty helpful just to get yourself in the right mindset and know what you're looking for. So we are going to use these factor charts for what we're about to do, and they will help us figure things out. So if you look, I just have the numbers in pink and then what multiplies to them over in blue. That is what the factor chart is. Also, before we get started, I want us to take a little quick refresher on what the greatest common factor is, or GCF, and find the greatest common factor for each of these. So 6, I want to write out all my factors, which if we look up at the factor chart is these numbers, and I'm going to write them in order 1, 2, 3, and 6. And then for the factors of 9, we can also look at the factor chart. These factors are 1, 3, and 9. We don't have to write the 3 twice. So the greatest common factor is simply the number that is the largest within each list. That is the greatest common factor, 3. That means we can divide both of these by 3 and still get whole numbers back. We want to do the same thing. Oops, this meant to be a 7. We want to do the same thing for this next problem. We want to write the factors of 27 and 54. Now you'll notice 54 is not on our factor chart. That's okay, we can figure it out. You can say that the factors of 27 based on our chart are 1, 3, 9, and 27. So we can find the factors of 54 if we want to do it like our factor chart. 54 has factors of 1 and 54. We know it's even, so it has to have factors of 2 and 27. 54 is divisible by 3. So we have 3 and 18. Then we have no 4, no 5. It is divisible by 6, 6 and 9. No 7, no 8, and then we already did 9. So we are good to go. That means we can put these in order here. So 1, 2, 3, 6, 9, 18, 27, and 54. Are factors of 54. So the greatest common factor here is 27. That means we can divide both of these by 27 and still get a whole number back. Okay? So those are just to get started here. We'll flip back to the actual notes that you have. So to factor quadratics in the standard form ax squared plus bx plus c, when a has to equal 1, notice to do it the way I'm going to teach you today, this guy up here has to equal 1. So this is 1, this is 1, and this is -1, but we'll fix that when we get to it. So I like to say that I need factors of C that either add or subtract to equal b. I'm actually going to move this up here. Because that is kind of the general form. So I need factors of 20 that, in this case, add, this sign in front of 20 tells us we need to add to equal positive 9. So factors of 20 add to 9. So if you look at your factor chart, you'll see that your factors of 20 are 1 and 20. Oops, let's put a multiply there. 2 and 10. And 4 and 5. Look at these pairs and decide which pair can add to equal 9. Whichever pair adds to equal 9 is going to be the pair that you use as your factor. Now we write factors as double parentheses. The squared up here means we need 2 parentheses, so we write x plus 4 and x plus 5, and that is actually our solution. I want to show you why this is true, or why these are actually equivalent to each other, by foiling. You might remember this from Algebra 1. We multiply the first terms, then the outside terms, then the inside terms, and then the last terms. Now this isn't actually part of our problem. I'm just showing you that these are actually equivalent. So if I multiply my first 2 terms, x times x becomes x squared. I multiply my outside 2 terms, x times 5 is 5x. My inside 2 terms is 4x. And my last 2 terms plus 20. Combine these like terms, I get x squared plus 9x plus 20. So the whole reason I did that was to show you that the factored form and the original standard form are truly the same. These guys are equivalent to each other. Alright, so we don't actually need to do that on any following problems, but that is there to check if you want to check your work. So this next problem works very similar to the last one. This time though, we want factors of 72 that subtract, because of the sign here, to positive 14. So the factors of 72, we can just start listing them out. 1 and 72, they are not on the factor chart, so you just kind of got to know. 2 and 36. 3 and 24. I don't know if 4 goes into it or not. 4 and 18. No 5 for sure. 6 and 12. No 7. 8 and 9. No 10. No 11. And we already have done 12, so we know we've exhausted our list. So we want to take a look at these groupings. Which pair of these could subtract to be positive 14? Turns out that 4 and 18 can subtract to be positive 14. We can have negative 4 and 18 within our parentheses to solve this quadratic equation. And then we're done. You could check by foiling to make sure it comes out to what it's supposed to above, but I can assure you that it will. These two, you can check multiply to -72, and then they add to +14. So we are good to go. This next problem, there's one extra step. We want A, ideally, to be +1. So what we can do is we can actually pull a negative out front, which then switches the signs of everything following. So then we have x squared minus 13x plus 12. And then when we have our final answer, just make sure to put this negative back in front. So now we need factors of 12. This time that add to -13. So our factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So which set of these can add to 13? Well, 1 and 12 do. The problem is they are currently adding to +13. So to make them add to -13, we just make them both negatives when we put them in our brackets. So x minus 1, parenthesis x minus 12. Don't forget this negative left on the outside. And we are completed. So we have our answers, our factors for all three of those problems. So you're looking for factors that then add or subtract to our middle B term. These next two are a little different, although they are similar to what we did early in the lesson. We want to find our greatest common factors. So these we're actually going to be factoring out, but the greatest common factor we want to find first. So I'm just going to write these down and then find the factors of each of these. So the factors of 6 by my little factor chart are 1, 2, 3, and 6. And then we also have n squared, which just is an n and an n. For the factors of 9, notice I'm putting them in numerical order, not in the order like the factor tree. This helps us view them easier. Are 1, 3, 9, and n. So the biggest number in the order is my greatest common number factor. And then if there are shared variables between every term, you can also use that as the greatest common factor. So the GCF, greatest common factor of this, is 3n. That means, like we pulled a negative out front on this previous problem, we can pull a 3n out front on these ones. This is basically just saying we are dividing each term by 3n. So take 6 divided by 3 and you get 2. Then take n squared, which is really just n times n divided by n. And you are left with 2n. Then you take 9n divided by 3n. The n's cancel out. 9 divided by 3 means +3. You have factored out your greatest common factor then. We first found it, then we factored it out. This next one is a trinomial, so we need to find the greatest common factor between each of these. 4x squared, 20x, and 56. So 4x squared, we have factors of 1, 2, 4, and x. 20, we have factors of 1, 2, 4, 5, 10, 20, and x. And 56, we have factors of 1, 2, 4. Let's see what else. 7, 8, 14, 28, and 56. So, the biggest number in all three lines, we actually could have not written any past this because we know there's no number bigger than 4 up here. But it doesn't hurt to also write all of them. So we know our biggest number in all three lists is 4. So we can factor out a 4. And then we can't factor out any x's because this last 56 does not have an x term. So the only thing, our greatest common factor here, that we can factor out is 4. So pull that out front. Divide each term by 4. So we are left with x squared plus 5x minus 14. Now, it did just ask to factor out the greatest common factor, but we can go ahead and do what we did above to completely factor like we did on these three. So this time, we are going to look for factors of 14 that subtract to positive 5. So just first look at the factors of 14, 1 and 14. 2 and 7. Look at these pairs, which one would subtract to 5? Well, 2 and 7 would. Since we needed to subtract to positive 5, we need a negative 2 and a positive 7. So we can write these as a factor, x minus 2, x plus 7. These two numbers multiply to negative 14. They also subtract to positive 5. Don't forget to bring down this 4 from above. And we have our solution here. Our factor, I should say. And we are done. That is all I have for you today. We will finish this lesson tomorrow with part 2.